Hi everybody. Today we're going to look at the bones of the horse's lower leg, both front and hind leg. So we'll start out with the bones of the horse's foreleg from just distal or just below the knee. There are 9 bones, and the common names for these bones are the cannon, 2 splint bones, 2 sesamoid bones, the long pastern bone, the short pastern bone, the coffin or pedal bone, depending on which textbook you will be reading or where you may have originated from, and the navicular bone. But the proper names for those of which we need to learn are slightly different. So if we start out with the largest bone of the lower part of the horse's leg, the cannon bone, the proper name for it is the large metacarpal. Also called the third metacarpal, and written as large M, small c. It's called the third metacarpal because the horse stands on its middle finger on the front end, on its middle toe on the hind end. The second finger and the fourth finger are the small metacarpals, and the middle finger is the large metacarpal. It's named the same in our own hand and our own feet. So on the front end it's metacarpal, on the hind end it's metatarsal. So large metacarpal or third metacarpal, which then that makes the split bones the MC2 and MC4, so the second metacarpal and the fourth metacarpal. Then distal to that, and on the back side, the palmar face, we have these small irregular shaped bones that are called the sesamoids, but they're called the proximal sesamoids. Anytime you see a term proximal or distal, it's a descriptor to identify a bone that has a similar bone further down in the leg but separate the two. So proximal means it's an indicator that there's another bone, another sesamoid somewhere else in the leg that does the same job but is in a different location. So that'll help you with the naming the bones further down. So then we get into the bones, the bones proper of the digit, and the first one, the long pastern, is called the first phalange, the first finger bone. And then we have the second phalange, and then the coffin bone is the third phalange. And this small bone here, of course, is the navicular bone, but is also called the distal sesamoid. I find the best way to learn things, especially in anatomy, is to do a rough sketch, a quick sketch of whatever the part is, and that's the best way to learn this stuff. So a quick sketch of this side view is a good place to start because it's the most common view we will have of the horse's body when we're working on it. So a side view like this with as close as possible an accurate description of the bones on your drawing. So now if we look at the palmar view and combine the two, you start to pick out distinct features of the bones. So if we start with the cannon bone, it's generally a long bone with a largish head and a tapering shaft and then a rounded distal end to it. So I have a specimen here. This is a freeze-dried leg. And if I turn it around, here we have, this is the knee of the horse, or the carpal joint is the correct term for it. And then we have the cannon bone here, so if I take this cannon bone off and we have a look at it. So you can see that it has a flattish top to it, a tapering shaft and a rounded end that has a median ridge I turn it upside down, it's quite clear that it has a median ridge and then a depression and rise to. So the center portion is called the median ridge, and the side portions are called condyles. So the shape of this joint, this bone, helps to make this joint where it articulates with the bone distal to it, the first phalange, make it a true hinge joint. So there's very little side-to-side movement on this joint, just forwards and backwards. So if we look at that bone placed there, and you can see that it has a larger head, tapering shaft, and then definitely a larger end to it. The small splint bones, the second and fourth metacarpals, lie on the, another model here, lie on slightly to the back face of the bone, and they have largish heads. They have a drumstick shape to them in that they taper significantly, and then they have a P end on them, which unfortunately is broken off this model. But they, combined with the large metacarpal, give a larger articular surface to the distal articulating face of the carpal joint. There is a difference between the medial and lateral small metacarpals. On the average horse, they will carry more weight on the medial side of their leg, so the medial small metacarpal is larger on its head portion than the lateral small metacarpal. So MC2 is bigger than MC4 on the front leg. It also has two articulating faces. You can tell which leg you're looking at, first of all, by the shape of the large metacarpal itself. It has a flattish shank to it, or shaft to it, rounded front surface, flattish back surface, or palmar face. And then if you look at the proximal articular end of it, you will see that it slopes down partially on the medial side, or rises up on the lateral side. And then there are two articular faces on the small metacarpal, the articular face of the small metacarpal. The medial metacarpal has two articular faces. So there's a number of ways to tell whether it's a near or an off, left or a right, and a front or a hind, just looking at the metacarpals. So again, the distal end of the metacarpal, you can see on my sketch here on the right, median ridge, and the other side is a condyle. Just above and behind the distal end of the large metacarpal, we have the sesamoids. The sesamoids are located on the back face, on the palmar face of the large metacarpal, and they articulate with the metacarpal, not with P1. They sit in position by soft tissue that holds them there. When this joint articulates, they will ride up and down on the articular face of MC3. They act as pulley wheels for soft tissue to pass over the back of the leg and around the corner and further down to an attachment point. They also effectively move the point of rotation further out, or the point of leverage further out on the joint. So the tissue that is coming around the corner has to be further away from the center of rotation of the joint, effectively allowing more work to be done. Then if we move distal on the leg, we have P1, the first phalange, which essentially is a copy of the large metacarpal, just scaled down to somewhere about a third the length. It has a large head, tapering shaft, and a larger distal body. The difference with it is, of course, on the proximal articular face, it has a groove to accommodate the median ridge, so it has median groove, and then it has depressions to accommodate the condyles of MC3. You'll see on the back face of that bone there is a V-shaped roughened area that you can see here, and that's for attachment of soft tissue. Again, it has a flattish back face, slightly rounded front face, and then on the distal end it reverses the shape that you saw in the joint surfaces of the large metacarpal and the proximal end of P1, in that the depression is on the proximal bone and the ridge or rise is on the distal bone. So there's a prominence on the median portion of P2, which fits into a depression on the distal portion of P1, makes it look somewhat like a saddle sitting over the horse's withers. So this will be termed a saddle joint, where this is termed a ginglymus joint. So a true hinge joint, less than true hinge joint here, allowing a little bit of sideways movement. The same, the same thing is replicated on the distal interphalangeal joint, the joint between P2 and P3. So then if we go to the middle phalange, P2, or second phalange, short pastern bone is the common term for it. Essentially, it's about half the length of P1. Again, a similar shape. It has a larger head, a tapering shaft, which of course is very short, but it has a bit of a waist. And then it has a larger distal articular face. It replicates the form that you saw in the joint formed of P1 and P2, in that it forms a saddle joint with P2 and P3. P3 is probably the most peculiar of all the bones that we look at, in that it is quite distinct. This is the bone that determines the shape of the horse's hoof. The hoof does not dictate the shape of the bone dictates the shape of the hoof. If you have a round, flat third phalange, you will have a round, flat bone. If you have a deeply arched third phalange, if the solar surface is very concave, you'll have a very concave hoof. If it's pointy, you'll have a pointy hoof. Any horse you look at, whatever the shape of that hoof is, the true shape is dictated by the shape of the bone within. This bone is peculiar in that it is perforated liberally with small holes on the front face or dorsal face, but there are very few holes on the solar face or palmar face. There are two substantial ones that are up in the arch of the bone, but on the flattish solar face, there are very few, if any, holes for blood vessels to pass through. The bone has a number of different surfaces. It is a large, sloping, arced dorsal face that describes a shape similar to the hoof. It has a prominence, the extensor process, that is the proximal and dorsal part of the joint surface. It has an articular face that articulates with the distal end of P2, and then it has a small articular face that articulates with the navicular bone. So it has two distinct articular faces. On the dorsal face that sweeps around to form the wings, the wing on most bones is divided by either a hole or a substantial notch that a large blood vessel passes through, and a gallery that can be easily seen for a portion of the wing before it disappears about midway towards the front face of the bone. It has a very precise distal border that can be quite rough and sharp. This border can be highly modified depending on the health of the horse and the condition of the horse and how it has been managed. The solar face has two large holes, one here and one here, as you can see in the drawing, and then dorsal to that, on the solar face or palmar face, it has a crescent-shaped roughened area, and that's for the attachment of one of the prime tendons that pass down the back of the leg. The deep digital flexor tendon attaches to this semi-lunar crest. It, of course, has an articular face that is divided into two depressions with a median ridge. So here's a half section of the bone. You can clearly see the hole in the wing. The wing of the bone can be quite modified depending on the edge of the horse, and that gallery going along the wing towards the front face of the bone or dorsal face of the bone. So the articular face has a median ridge, but not as pronounced as on the distal end of MC3. It has a depression on the other side of that ridge which the distal end of P2 fits into, again forming a saddle type joint like this. So P2 drapes over the median ridge as if a saddle drapes over the withers of a horse. The last bone we look at is the navicular bone, and it is hidden in between the wings of P3, and it is called a sesamoid because it behaves exactly like the sesamoid of the more proximal end of the horse's leg. So here's the proximal sesamoid, here's the distal sesamoid. The tendon runs down the back of the leg, around the corner, and around the corner. The distal sesamoid, navicular bone, behaves exactly the same as the proximal sesamoids. It works as a fulcrum or a turning point for soft tissue to go around the corner, and essentially dictates that the deep flexor tendon always inserts or always approaches the semilunar crest of P3 at exactly the same angle, no matter what position the horse's leg is in. Okay, so what else do we need to know about the bones of the lower part of the horse's leg? First off, all bones, even though they seem like they're pretty solid and unchangeable, of course this is a dead bone, but in the live horse, bone is very changeable. Bone starts out as a cartilage template. In the embryo, all the bones of the horse's body, all the bones of our body, start out as plastic templates, and gradually during the development of the fetus start to change from plastic to what we would be more familiar with, that hard, rigid structure. But when a foal is born, not all of the cartilage has disappeared and been converted to bone. So when the animal is born, most of the cartilage is gone, but still some of it remains. P3, while still in an immature shape, no longer has any cartilage that's going to change to bone. It just is going to develop some more in shape and size. The navicular bone no longer has a cartilage template, but P2 has an amount of cartilage, and we call it a growth plate. So that is located about there on P2. There's another growth plate on P1, on the proximal end as well, and there is a growth plate on the distal end of MC3. The proper term for those growth plates are physis. When a horse has inflammation of the growth plate, it's called physitis. Anytime you see itis on the end of a word, it means inflammation. It's a way of shortening the sentence without having to use many words. So physitis is inflammation of the growth plate. The common term that is used for this condition in everyday use by horse people, vets and farriers is epiphysitis. And it may not be exactly precise, but it's good enough because the inflammation is of the end of the bone, proximal or distal end of the bone. So that looks like this. Epiphysitis. The end of the bone, so this area of the bone is, try to do a little better job here. That end of the bone and that portion of the bone is called the epiphysis, and the rest of it is called the diaphysis. So the main shaft of the bone, or the major portion of the bone, is called the diaphysis. The ends are called the epiphysis. If it has a movable end that moves against another bone, so this area or this area, that will be called the articular face. On the palmar face of the large metacarpal, you'll find one large hole for a large blood vessel to pass through. And if you were to take a magnifying glass, you would notice that there are lots more smaller holes. And of course, on the third phalange, you'll see lots of holes. That is called a foramina. So on this bone, there's a large hole right there, but there are numerous other smaller holes for blood vessels to pass through. The interior of the long bones is hollow, so essentially it's a pipe, which gives it substantial strength without a lot of weight, which is important, of course, because the horse gallops so fast. The hollowed center of the bone may not be totally placed dead center. It may be a little bit thicker on one side than the other, and as you can see on this bone, it's thicker on the front wall and thinner on the back wall. And if the cut was side to side from medial to lateral, you would see that the bone may be thicker on the medial and thinner on the lateral. Most horses tend to carry more weight on the medial face, on the medial portion of the leg. In the living horse, bones are not static. They are remodelable in a good way or a bad way, depending on circumstances. The most adaptable bone of the horse's leg will be the third phalange, or the coffin bone. If you have ever worked on a horse that's suffered from founder, that bone of that horse will have changed substantially because of the disease. This bone is not meant to sit flat on the floor, so it's not meant to sit like that. It's supposed to sit at an angle to the floor. The horse actually hangs by the front face of this bone. The front face of the bone is attached to the inner face of the hoof wall, and it hangs from that attachment. So essentially, the horse is hanging by his fingernails. If, the closest we could get to it would be if we were to put our fingernail on an edge like that and push down, we would feel pressure on the underface of our fingernail. That's what the horse should be feeling in a healthy hoof all the time. Not so much load on the bottom of the foot as load actually from above, from the front face. Again, all the bones of the horse's leg are remodelable. Conditioning will cause them, proper conditioning will cause them to get stronger. Improper circumstances will cause them to deteriorate. If diet is not ideal, the horse will lose bone because of reduction in mineral. The bone actually acts as a kind of a mineral bank, and the body will take minerals out of the bones as the body needs them. A common example we have is osteoporosis in people. Horses will suffer from the same thing. Bones will get thicker if the conditioning is correct, so working on a surface that will cause compression of the bone, but not too much. An example would be a horse that goes to the racetrack. Some individuals will develop microfractures because they're being worked too hard, too fast. The bone cannot remodel quick enough to accommodate the workload that's placed on it. Of course, bones will fracture, and those can heal. Where it's most traumatic for the horse will be a fracture that involves the articular face. One of the most common bones to fracture in the horse's leg is the third phalange. Because of its peculiar shape, a wing can break off, could have a chip on the distal border, or it could have a fracture right through the middle, so that it would involve the articular face, which will be much more traumatic for the horse. It's not unusual for a navicular bone to fracture, and the first phalange or second phalange, and of course the large metacarpal, being that long, can fracture. On the hind leg, the only difference that we need to remark on is the naming of the cannon bone. It's not the large metacarpal, it's the large metatarsal. Because the joint above it is the tarsal joint, and there are 2 rows of tarsal bones. The large metatarsal is slightly longer and is rounder in the individual horse. So if you had 2 cannon bones, one front and one hind, you should be able to tell which is which. The cannon bone of the front leg will be shorter and it would be flatter. The cannon bone of the hind leg would be slightly longer and much rounder. And then, of course, the split bones of the hind leg are called the small metatarsals, MT2 and MT4. The other difference is the pastern bones, P1 and P2, are named the same, but the lengths are slightly different. P1 is slightly shorter and P2 is slightly longer. And then, of course, P3, since it dictates the shape of the hoof, is going to be more of that familiar hind shape. Pointier toe, slightly straighter sides, but of course totally dependent on the individual horse. The closure times of the physis, I didn't cover that. So, nature closes the growth plates distally, working proximally. So the first one to close, there was a growth plate of P3, but it had long disappeared, so there is not one the foal is born. There is a growth plate of P2. That one closes first at about 3 months. That's not a precise date, and the term closed just means that there is minimal cartilage and the bone is essentially becoming one instead of 2 pieces with a cartilage area gluing the 2 together. The next one to close is the physis of P1, and it closes about 6 months. Then we have the physis of the distal end of MC3, and it closes about 9 months. Each of these growth plates is an opportunity to do some remedial work on a juvenile horse that has less than perfect conformation. The most effective work will be on the growth plates that are closest to the hoof. When this one closes, an opportunity has disappeared. So as each one closes, the ability to do any remedial work as far as improving the conformation of the horse has been lessened or removed. So the only other thing we need to cover now are the particular parts of the third phalange, P3, coffin bone or pedal bone. So there are a number of specific parts that we really should be aware of, because essentially when we're shoeing a horse, we're shoeing this bone. We have a prominence, the most proximal end of the bone is the extensor process or pyramidal process. So this pointy top, it's an attachment point for an important tendon, the extensor tendon. Then we have the dorsal face, so that's all of this sloped face is the dorsal face. We have the distal border, which is this sharp, roughened edge, is the distal border. We have the solar or palmar face, which is the bottom face. So this face, it may be flattish or it may be quite arched depending on the individual animal, and then whether it's front or hind. On that face, it can be divided up into the semilunar crest, which is this arched area here, which again is an attachment point for the opposing tendon, the deep digital flexor tendon, which opposes the pole of the extensor tendon. We have the articular face, which is divided by the median ridge, And then of course we have the wings, the back part of the dorsal face, and that is divided by either a hole in this one within a gallery that you can see a large blood vessel used to sit in, and the roughened perforated edge of the wing. On this side, that hole is not a complete hole, it's just a notch. So this bone is displaying a nice asymmetry of features here, in that a notch on one side, a hole on the other side, suggesting that the wings are very remodelable on an individual horse. It looks as though this individual was probably quite flat-footed, in that the back part of the bone, some of it seems to be missing on the wing. It's very rough and very sharp. It looks as though some bone is being lost. Then the other things that we can look at would be some bones will have a notch or a piece that appears to be missing on the distal border, and that is termed a crenna. And then the one other feature is that you should be aware of is the terminal arch, which is not on the outside of the bone. Some people confuse the semilunar crest, which is this structure, with the terminal arch, which actually lies within the bone. I have excavated this bone so you can see that there is a gallery or a tunnel that a blood vessel lies in, passed through this large foramina and looped around the terminal arch, and there's another blood vessel that passed through this foramina and they combine inside the bone, which is unusual. You have two large arteries passing through these foramina. So again, there are a number of different features of the third phalange, and of all the bones, this is the bone that you should study the most, because this is the bone that dictates what the shape of the hoof should be, and we can determine that by the shape of the white line, because the white line is produced off the distal border of the third phalange.